A very good morning to all of you. Today unfortunately I cannot present you the live class. That's why I have recorded the video, and hopefully next week onwards we are going to have live class. Okay, so as you know, CBSE has published a new syllabus and all of us are following the syllabus. You also have to follow the syllabus. Now what you will do, your term 1 syllabus has been completed, right? So what are the chapters which are there in term 1? I guess you already know that. The chapters which are there in term 1 are: number 1, solid state; number 2 is solution; number 3 is P block elements; number 4 is haloalkanes and haloarenes; next one is alcohol, phenol and ether, and the last is biomolecules. Okay, so these are the chapters which are there in your syllabus of term 1, and the rest of the chapters are there in term 2. Okay, a few chapters have been removed, and these chapters are extraction of metal. Okay, then the last 2 chapters, chemistry in everyday life and the chapter called polymer. These chapters have been removed completely by CBSE. So rest all the chapters are there in your syllabus. Okay, and a few things are there which have been removed. Few portions of the chapters have been removed by CBSE also, that you will follow. You have the PDF, I guess, so just do watch the PDF and follow that. Okay, so what we will do, we are not going to discuss these chapters again and again. Before your exam we will have some revisions. Okay, exactly what we do, like what we did in your last exam, during the last exam. So I am not going to discuss these topics as of now. So instead of that, what I will do, I will discuss chemical kinetics, and we will try to cover the syllabus of term 2 as much as possible, because the reason is later on you will get a very less time for the term 2. Okay, it's a big syllabus, and see, your time will be a little bit short for term 2. So it is better to continue the term 2 syllabus little bit from now onwards. Okay, so we will continue the chemical kinetics, what we were discussing previously. Chemical kinetics, a very important chapter of your syllabus. See, what we have to discuss in chemical kinetics today, a very important factor that we need to discuss in chemical kinetics is what are the factors that affects the rate of the chemical reaction. So factors affecting the rate of a chemical reaction. Okay, so these are the factors that I am going to discuss now. These are, first of all, number 1, the concentration of the reactants. Number 1, the concentration of the reactants. Okay, see, the concentration of the reactant is directly proportional to the rate of the reaction. That means the concentration of reactant is directly proportional to the rate of the reaction. Okay, if the concentration increases, the rate of the reaction will also increases. Okay, the second factor is nature of the reactants. The second factor is nature of the reactants. Okay, also the rate of the reaction depends on the nature of the reactant. Okay, if the reactants are ionic, the rate of the reaction is faster. If they are covalent, the rate of the reaction is quite slow. Okay, so example, if reactants are ionic, the rate of the reaction is faster. Okay, the rate of the reaction is faster. So this is the factor. Okay, the next factor that we have to discuss is temperature. The next and the third factor that we need to discuss is temperature. Okay, temperature is another important factor. Okay, if you increase the temperature, the rate of the reaction increases. And a very important fact is that with increase of 10 degree, okay, the rate of the reaction increases twice, or rate of the reaction becomes double. Okay, the rate of the reaction is doubled with increase in the temperature by 10 degree. Okay, so this is a very important factor. The next factor is surface area of the solid. The next factor is surface area of the solid. With increase in the surface area, the reaction rate increases. Okay, with increase in the surface area, the reaction rate increases. Okay, as many of the reactants can bind together, so it increases quite easily. Okay, I hope you have understood. Now the last and the final factor is influence of a catalyst. Okay, the last and the final factor is the influence of the catalyst. Let me erase this. Factor number 5. Factor number 5 is influence of a catalyst. Now the question arises, how a catalyst can influence the rate of the reaction. See, simply we know that what is a catalyst? A catalyst is a chemical substance which generally increases the rate of a chemical reaction. Okay, it is not visible, so let me write it over here. Influence of a catalyst. Okay, now it is visible. Influence of a catalyst. Okay, see, a catalyst is what? A catalyst is a substance. A catalyst is a substance which increases the rate of a reaction. Rate of a reaction. Okay, without participating in the reaction, without participating in the reaction. Very simple. We know that this is basically catalyst. It readily increases the rate of a reaction, but it does not participate in that particular chemical reaction. So obviously we know that a catalyst will always increase the rate of a chemical reaction. Okay. So these are the factors on which the rate of a chemical reaction depends, or these factors can affect the rate of a chemical reaction. Alright, so the next thing that we have to learn is the law of mass action. Okay, the law of mass action. Law of mass action, or you can also call it mass action principle. Okay, what does this mean? This simply means that if there is a chemical reaction, okay, now the rate of the chemical reaction is directly dependent on the concentration of the reactants. Again, the rate of the chemical reaction is directly proportional to the concentration of the reactants. Okay, and we have to keep that in mind. We need to take the stoichiometry as the power of the concentration term. Okay, for example, this is the chemical reaction A plus B giving us some product C. Okay, now what mass action principle says that? The mass action principle says that the rate of a chemical reaction is directly proportional to the product of concentration of A and B. Okay, product of concentration of A and B. See, the third bracket I have used, this is used to write the concentration. All right, now there is a proportionality sign. We can remove that proportionality sign, so rate is equals to some constant into concentration of A into concentration of B. Now the constant that I have written here is basically known as the rate constant. K is the rate constant. All right, now another factor is there. The factor is if there is a stoichiometry. For example, the reaction is something like this, AA. Okay, let's take some arbitrary number, 2A plus 3B. Okay, 2A plus 3B giving us C. So during this rate law or law of mass action principle, you have to write it like this: rate is proportional to concentration of A to the power 2 and concentration of B to the power 3. Okay, so this is how it is written. So this is basically the rate law of the, or so not rate law actually, law of mass action principle. Okay, now what we need to learn is the rate law. Rate law. Now what do you mean by rate law? See, in the last day's class we have learned how to write down the rate of a chemical reaction. Okay, for example, let's take this example only. Okay, the rate can be written some like this. So minus half into concentration of A by dt is equals to minus 1/3 into concentration of B by dt is equals to K into concentration of A square into concentration of B cube. So this entire thing is known as rate law of a chemical reaction. This is very important on the context of our study. This we have to understand, this we have to use, we will have to use. The applications are there. Okay. So we have now learned how to write down the law of mass action and we have also learned how to write down the rate law of a chemical reaction. Now some very important factors that we have to understand. Some important factors. Okay, what are these factors? Very important factors. Let's discuss. The number one factor is that, see, the rate law. Okay, the rate law is basically deduced experimentally. Okay, see, it's basically experimentally. So we have written this. While writing this, we have used these numbers. Okay, so we can say that the thing that we have written here is theoretical, but actually the rate of a chemical reaction is an experimental factor. Okay, so it is quite obvious that every time you will not see that these things will be equal, they will not match. Okay, let me give you an example. A very simple example is this reaction 2NO2. Let's write it over here. No, let's write it over here only. 2NO2 gas, okay, plus F2. Okay, they will combine and they will give us 2NO2F. Okay, this is the chemical reaction. Okay, 2NO2F. Now the reaction rate, basically the experimental reaction rate of this reaction is something like this. Rate is equals to concentration of some constant into concentration of NO2 into concentration of F2. Okay, you will not write the stoichiometry as a power. Okay, this you need to understand. Now if you try to write down the entire rate equation or rate law, you can also call it. So how will you write this? Like I am writing it over here, half into d of NO2 dt. Obviously a minus will be there, equals to minus ddt of F2 equals to this one, K into NO2 into F2, K into NO2 into F2. So this is basically the rate law of this reaction. Now as you can see, this will not match. Okay, so this we have written, okay, theoretically on the basis of the assumption or the basis of the stoichiometry that we have taken here, but experimentally they might not match. Okay, so keep that in mind. It's a very important factor of this chapter or of this study of chemical kinetics. Okay, now order of a chemical reaction. Let me erase this. If you want to write, you can pause the video and you can write these things. Today PDFs obviously will not be available. So next thing is order of a chemical reaction. Order of a chemical reaction. Okay, order of a chemical reaction. Now what is meant by the order of a chemical reaction? See, what we have discussed during writing the rate equation, we can definitely take the stoichiometry as the power of the concentration term of the reactants. Now if you add these concentration terms, okay, no, sorry, no, not concentration terms, the exponential terms or the powers, okay, then the addition of all the power is basically the order of the reaction. And if you particularly take a single reactant, Okay, and if you take the power of that reactant, then obviously it will be the order of that reaction with respect to the reactant. Don't worry, everything I will be explaining. So it is basically the sum of powers of the concentration terms. Okay, an example, let's take a simple example. Okay, again I am considering the experimental factor because we have to consider a rate equation. Okay, suppose 2a plus 3b giving us c. Okay, let's suppose the rate of the reaction is something like this: k into a square b cube. Okay, so the order of the reaction see, we can write it in more than one way. So if you want to write the order of the reaction, it is 2, but with respect to A. Okay, it is 3, but with respect to B. Okay, it is 3 plus 2, 5. Okay, this 5 is the overall order. This 5 is the overall order of this chemical reaction. Okay, this is how we have to write down the order of the chemical reaction. For example, let's take the previous reaction, NO2 plus F2 giving us NO2F2. Okay, 2NO2. So this is the reaction. Now the rate of the chemical reaction is some constant into concentration of NO2 multiplied by concentration of F2. Okay, so this reaction has the order of 1 with respect to NO2 and the order of 1 with respect to F2. Now what do you mean by the overall order? Overall order is equals to 1 plus 1, that is 2. This 2 is the overall order. You just add the powers, all the powers, and what you will get? You will get the order of the chemical reaction. Alright, so this is the way of finding the order of the chemical reaction. Now some important factors regarding order of the chemical reaction. Let me erase this. Some important factors regarding the order of the chemical reaction. Some important factors. Regarding the order of the reaction. Okay. Some very important factors are as follows. Number 1, the order can only be written on the basis of the experiments. Okay. Number 1, the order of a reaction can only be written or only be calculated on the basis of experiment. On the basis of experiment. So which means it's a complete experimental data. Okay. Number 2, first of all, the order of a chemical reaction is completely an experimental data. Okay. Number 2, the order of a chemical reaction, the order of a chemical reaction can be integer, okay, can be fraction as well. It can be an integer, it can be a fraction. So both the possibilities are there. The order can be -1, it can be -2, -5, 1/2, 1/5. Anything can be possible in case of order. Okay. These are the two important factors. Thirdly, the order of a reaction depends on the concentration of the reactants. Okay. Some reactions are there. Okay, let me tell you one thing. The order of a chemical reaction can be integer, can be fraction. It can also be 0 as well. Okay. The number 4 is, there are some reactions with no specific order. Okay, there are some reactions of which we cannot predict the possible order. Okay, right, the overall order. Okay, not specific, the overall order cannot be predicted properly for some particular reactions. Okay, so these are basically order. So a reaction can be of 0 order, a reaction can be of first order, second order, third order, fourth order, nth order. So all the possibilities are there. So in your syllabus we will discuss 0 order and first order reaction only. Okay, in higher studies we have more type of order of the reaction, second order, third order. So these are also there. Okay, so today we are not going to discuss further. Today I am going to stop here only. So next day we will deduce the 0 order reaction, the first order reaction, okay, the rate law basically of the 0 order reaction and the first order reaction. Okay, and we will also learn about molecularity. Okay, we are almost at the end of this chapter. Okay, after discussion of molecularity we will discuss the numericals. Okay, what are the important numericals from this chapter? Gradually we will discuss. Okay, so that's it for today. Thank you everyone. Let's meet on the next Friday.